The Pacific theater is defined primarily by the tyranny of distance and the unforgiving physics governing long-range logistics and kinetic penetration. In this vast maritime expanse, a target located 500 miles inland is protected by layers of geography and sophisticated integrated air defenses. The United States military currently relies on the Tomahawk cruise missile, a weapon costing $2 million per individual unit, for deep strike capability. Mathematical models of high-intensity conflict suggest that hundreds or even thousands of these high-value munitions would be required in the opening phase. At $2 million per shot, the fiscal logic of sustained attrition collapses long before the military objectives are achieved on the ground. Current inventory levels are optimized for short, decisive campaigns against insurgencies, not a protracted industrial-scale conflict against a peer-state adversary. Every launch from a vertical launch system cell represents a depletion of a limited strategic reserve that cannot be replenished in real time. Meanwhile, the adversary has pivoted to an asymmetric strategy, fielding thousands of low-cost drones, decoys, and expendable systems to saturate American sensors. This creates a structural imbalance where the United States is forced to expend million-dollar interceptors and strike weapons against $10,000 wooden targets. This systemic failure is known as the range cost problem, a reality the Pentagon has largely ignored during 2 decades of uncontested aerial supremacy. For years, precision was marketed as an expensive luxury that guaranteed short wars, but the era of the brief, surgical conflict has ended. The assumption of a permissive electromagnetic spectrum and uncontested airspace is no longer a viable foundation for American regional strike doctrine. Modern peer adversaries have turned the First Island chain into a lethal thicket of radar-guided missiles and electronic warfare nodes designed for denial. Exquisite weapons like the JASSMER are individually effective, but their high manufacturing complexity prevents the mass production required for a war of attrition. The strategic question has shifted from how to build a more lethal missile to how to sustain a high-volume fight without bankruptcy. L3 Harris has identified this inflection point and proposed a dual-system solution designed to flip the cost curve in favor of the United States. These systems, designated Red Wolf and Green Wolf, represent a fundamental departure from the legacy philosophy of gold-plated, low-volume munitions and platforms. To understand why these systems are necessary, one must first analyze the physical limitations of existing American long-range strike architectures. A Tomahawk can hit a specific window from 1,000 miles away, but it is an over-engineered solution for 80% of tactical targets. Hardened command nodes require heavy warheads, but the vast majority of an adversary's operational strength lies in soft, relocatable, and distributed assets. Striking a fuel truck, a mobile radar, or a parked fighter jet with a $2 million cruise missile is a tactical success but a strategic loss. Sustained pressure on an adversary's logistics and airfields requires a weapon that can be fired in bulk and produced at industrial speeds. Attrition warfare is ultimately won by the side that can absorb losses while maintaining a higher rate of effective kinetic output over months. Long range has traditionally mandated massive propulsion systems, advanced seekers, and complex airframes, all of which drive the unit cost towards 7 figures. Survivability through stealth or extreme hypersonic speed further complicates the engineering, adding layers of cost that prohibit the scale needed for saturation. When these factors converge, the result is a silver bullet arsenal that is too precious to use and too few to win. The Red Wolf program addresses this by prioritizing good enough precision and range over the pursuit of absolute, exquisite, and unaffordable technological perfection. Red Wolf is a long-range kinetic strike munition designed to achieve a reach of 500 miles while remaining economically expendable in high numbers. It is engineered for modularity, allowing launch from standard maritime, ground-based, and aerial platforms without the need for specialized, heavy-lift integration. By reducing the warhead size to match the target set of light vehicles and radars, Red Wolf shrinks the physical footprint of the entire system. This smaller form factor allows a single platform to carry a higher density of weapons, increasing the volume of fire per engagement. The defining characteristic of the Red Wolf system is its high degree of onboard autonomy, specifically designed for the dark environments of modern war. Legacy cruise missiles often rely on continuous GPS updates and umbilical links to human operators, both of which are vulnerabilities in a peer conflict. In the Indo-Pacific, GPS jamming will be the baseline operational condition, rendering traditional satellite-dependent navigation systems unreliable or entirely useless. Red Wolf utilizes a sophisticated suite of onboard sensors and edge computing algorithms to navigate through terrain referencing and inertial measurement units. This enables the weapon to identify and engage targets even when the electromagnetic spectrum is completely saturated by enemy electronic warfare. The missile does not merely fly a pre-programmed path. It possesses the onboard intelligence to adjust its trajectory based on real-time sensor data. If a primary target is moved or destroyed, the Red Wolf can autonomously transition to a secondary objective without requiring a signal from the rear. Multiple Red Wolf units can coordinate their arrival times and angles of attack to overwhelm a specific air defense battery through sheer saturation. Because the unit cost is significantly lower than a Tomahawk, the loss of individual missiles to interception is an expected part of the calculation. This shift in mindset allows commanders to take aggressive tactical risks that were previously unthinkable with a limited and expensive inventory. However, the kinetic strike is only half of the equation. The intelligence required to find targets is just as critical and equally contested. Traditional ISR relies on multi-billion-dollar satellites and manned aircraft, like the E-3 Sentry or the EA-18G Growler for electronic attack. These high-value assets are increasingly vulnerable to long-range interceptors like the PL-15, which are designed to blind the United States early. Pushing a manned Growler into the teeth of a modern integrated air defense system is a risk that modern commanders may not be willing to take. This is where Green Wolf enters the tactical framework, serving as the non-kinetic, sensor-heavy counterpart to the Red Wolf kinetic strike munition. Green Wolf utilizes the same airframe and propulsion as its kinetic sibling, but replaces the explosive payload with a modular suite of sensors. It is designed to loiter in contested airspace, mapping enemy radar positions, jamming communications, and identifying targets for the Red Wolf swarm. By deploying Green Wolf, the military can push electronic warfare and reconnaissance capabilities directly into the danger zone without risking a single pilot. Together, these two systems create a synergistic loop where the hunter-killer relationship is automated at the very edge of the battle space. The integration of Red Wolf and Green Wolf creates a distributed strike architecture that fundamentally breaks the centralized control bottleneck. By delegating coordination to the systems themselves, the military can maintain high-tempo operations even when satellite links are severed. This shift from platform-centric to network-centric warfare allows for a level of resilience that traditional strike packages cannot match. In a legacy engagement, the loss of a single jamming aircraft could jeopardize the entire mission and every pilot involved. With the Wolfpack system, the mission logic survives as long as a single Green Wolf remains to provide the necessary targeting data. This creates a self-healing strike net where individual units compensate for losses in real time without needing a human in the loop. The primary impact of this technology is the immediate alteration of the attrition calculation in the Pacific theater. Losing a $2 million Tomahawk is a significant blow to both the tactical mission and the long-term national treasury. Conversely, a Red Wolf is treated as a high-performance consumable, a tool designed to be used and lost in the pursuit of mass. This economic reality allows commanders to sustain a higher operational tempo, launching strikes day after day without exhausting their inventory. High-volume production lines for these systems can be stood up in weeks, rather than the years required for advanced stealth munitions. Beyond the economics, this system forces a radical restructuring of how the United States projects power at a distance. Reliance on a small number of massive, nuclear-powered aircraft carriers is a vulnerability that peer adversaries have spent decades exploiting. A single carrier represents a concentrated point of failure. Its loss would effectively end American participation in a regional conflict. The Red Wolf and Green Wolf systems can be distributed across hundreds of small, unmanned surface vessels or modular ground launchers. This distributed lethality makes it impossible for an adversary to neutralize American strike capacity with a few well-placed shots. Every shipping container, every small patrol boat, and every hidden truck becomes a potential launch point for a long-range swarm. Furthermore, this architecture removes the absolute requirement for aerial refueling tankers, which are soft targets in a contested sky. By launching from the sea or land and flying 500 miles, these weapons bypass the need for vulnerable forward air bases. This brings a massive range of targets back into play, targets that were previously considered too cheap for a $1 million missile. In a prolonged conflict, the destruction of a secondary fuel depot can be as strategically significant as hitting a primary command center. Logistics wins wars, and the ability to systematically dismantle an enemy's supply chain at scale is a decisive advantage. Imagine an adversary's airbase, where every parked aircraft and every radar dish is simultaneously targeted by dozens of small, cheap munitions. The goal is not just destruction, but total operational paralysis through a relentless, low-cost thousand-cut strategy. This represents a quiet revolution in military thought, a move away from the first day of the war fetishization of stealth. Modern military planning has been obsessed with the opening hours of a conflict, neglecting the messy, exhausting weeks that follow. Red Wolf and Green Wolf are not designed for the clean, surgical strike. They are built for the grinding reality of industrial age attrition. They recognize that in a fight against a peer power, the enemy gets a vote, and that vote will be violent and disruptive. The adversary will jam your sensors, they will hack your networks, and they will try to bankrupt you through asymmetric defense. Success in this environment requires systems that are attritable, effective enough to win, but cheap enough to lose without regret. L3Harris has designed these systems to be modular, allowing for rapid software and hardware updates as the threat evolves. If a new enemy radar frequency emerges, a software patch can be pushed to the Green Wolf fleet overnight to counter it. This rapid iterative cycle is the only way to stay ahead of an adversary that is also innovating at the speed of software. The physical airframe of the Wolfpack is secondary to the algorithms that drive its autonomous cooperation and targeting logic. We are entering an era where the smart component of the weapon is decoupled from the expensive, exquisite airframe. This decoupling allows the United States to leverage its lead in artificial intelligence and edge computing to offset its industrial disadvantages. While the adversary can build more steel, the United States aims to field more intelligence per cubic inch of the battle space. The sustainability of the Indo-Pacific defense posture depends entirely on this transition to mass-producible, autonomous strike systems. Red Wolf and Green Wolf are the first credible attempts to solve the range cost problem without sacrificing the reach required for the Pacific. They provide a bridge between the high-end silver bullets and the low-end suicide drones that lack the range to be relevant. This middle-tier capability is the missing link in the American kill chain, providing volume where it is currently most lacking. As production scales, the cost per effect will continue to drop, creating a virtuous cycle of military and economic efficiency. The shift is not flashy. It lacks the sleek aesthetic of a hypersonic glider or a sixth-generation stealth fighter. However, in the cold logic of system-level conflict, the boring, sustainable, and numerous weapon is often the most dangerous. History shows that wars of attrition are won by the side that can keep its factories running and its magazines full. By prioritizing sustainability over dominance, the U.S. can ensure that it never runs out of options in the middle of a crisis. The Wolfpack system isn't just a new missile. It's a declaration that the era of the unlimited budget war is over. It is a pivot toward a more disciplined, calculated, and ultimately more lethal form of warfare tailored for the 21st century. When the 100th day of the conflict arrives, and the exquisite missiles are gone, the Red Wolves will still be flying. This is the future of long-range strike, affordable, autonomous, and absolutely relentless in its pursuit of mission success.